Today we're going to add fractions with a factorable denominator and also this change signs rule that we've been dealing with. And I noticed on the study guide that we just did that there's a problem like this on the study guide too. So the test you're going to be taking on this Thursday, this happens. I don't recall us not having covered this before, but I don't know, we'll see. But there's a problem like this on the study guide, so hopefully you get a chance to practice it well before the test. First off, I noticed there's a factorable denominator, so I always want to factor things completely before I start worrying about common denominators. The most common mistake people make here is they just do this times this for a common denominator, which works, but it's not the least common denominator. Your expression will be a lot more ugly to look at and a lot harder to deal with. If you can find some factored form and some common factors, it makes it easier. So if I'm looking to factor x squared minus x minus 6, two numbers multiply to make negative 6 that also add to make negative 1 would be negative 3 and positive 2. So x minus 3, x plus 2. There's a possibility of reduction also. If that happens, it's worth doing. But obviously, those aren't the same, right? X plus 3, x minus 3 aren't the same. So we can't reduce. And then I got minus 3 over 3 minus x. And keep in mind, 3 minus x, I'm going to put that in parentheses to treat it as one object. What I want to do before I start worrying about a common denominator is do some comparison of things and see if there's anything the same, so I can maybe get a smaller common denominator than I would otherwise. And I'm looking at these two things in particular, x minus 3, 3 minus x. They look the same, but not, right? Signs aren't the same. So this rule that we came up with earlier this year, which says that if I change the signs in one location and a second location, that's legal, right? And my recommendation is always, if the front object is negative, change it. If the front object is positive, change the top. All right? By doing that change there, so this x became positive, this 3 became negative, so both signs changed on the bottom, so that's one sign location change. The front changed also, that's 2. We always want to do 2 location changes. Once we change the signs of both locations, now this fraction is equivalent to the original, but now x minus 3 matches x minus 3. So if I just get an x plus 2 on the bottom of this fraction, which requires me putting x plus 2 on the top of that fraction, now x minus 3 times x plus 2 is a common denominator for both fractions. So if I just create that denominator, x minus 3 times x plus 2, the first numerator is just x plus 3. We didn't have to do any modifications to that because it already had the common denominator we wanted. The second numerator has a positive 3 being multiplied by x plus 2, so I'm going to distribute positive 3 times x and positive 3 times 2. The final step of simplification is, if there's like terms, you need to add those together. And that same thing will happen on the test. Again, a problem similar to this type. All right, so x and 3x make 4x. 3 and 6 make 9. All over x minus 3 times x plus 2. And that would be the best answer for that. If you want to remultiply the bottom out, you can. You don't have to. I usually leave it factored. So mine would look like this. But again, that's just something to look for. Factoring, comparing factors, and if you have to do some sign change to make them the same, that is legal. And it's much easier than just multiplying this times all that. It makes for a nicer expression.